Welcome to video lessons 7.2 and 7.4. I'm combining these two into one video for us, starting off chapter 7. Even though we've been doing hands-on equations in class, this is the next step away from hands-on and just paper pencil. Please fill out your table of contents. Page 78 is where I'm at. And we're going to have solving algebraic equations. If you can add the symbols addition and multiplication to this, that would be awesome because we are going to be dealing with those kinds of equations. You just need your little half sheet to glue up at the top of it, and then you're going to use the rest of the notebook paper to do some problems, as you can see. So here's some fun comics to get us started. Wait just a minute. Yesterday you said x equals 2. Obviously, when we're solving algebraic equations, x or the variable changes depending on what it's equal to. And here's another little humorous one. If x is unknown, why should I rock the boat and try to solve it? So just a little humor to get us started. And now we'll fill this in. The biggest thing to remember is that when you have addition going on in an equation, you have to use subtraction as the inverse operation. Remember, inverse from our properties means opposite. So if you have addition in an equation, how to get rid of it would be to use the opposite operation, and addition and subtraction are going to be inverse operations. Similarly, multiplication, you're going to use the inverse operation of division. So multiplication and division are now going to be paired as inverse operations. If you want to get rid of multiplication, you do so by dividing. The goal for all of these is to get all of the variables on one side and get all of the constants on the other, so that at the end of the day you have x equaling a number, or a equaling a number. The variables are going to change now. I know they were just pretty much x's when we were doing hands-on equations. I know on your note sheet there's another box. We're going to save that for a little bit later. And so on the notebook page, we're going to start doing some examples. Where am I getting these examples from? Well, remember this lovely hands-on equation packet. If you go to the page called Lesson 2 Extra Practice, and then I'm also going to be pulling from Lesson 4 Extra Practice. So I want you to make sure you have that, because I'm going to ask you to pick your own examples from that sheet. I'm pulling from example 1. So in your notebook page, we're going to just label it example 1. And we're going to copy down the equation x plus 4 equals 14. That's the first step. When you're solving equations and you don't have hands-on manipulatives, you first start with the equation. Similarly, from our work with hands-on equations, we are splitting this up from the left to the right. You have to make sure what you're doing to the left, you also do to the right side. Since we see an addition, we know that we have to take the opposite operation, and so we have to get rid of that plus 4. How do we do that? We have to subtract a 4. And if we do it on the left, we have to also subtract 4 on the right. This becomes 0. Notice I drew a circle around it and crossed it out. That becomes 0. It goes away. On the right, we can subtract and get 10. The only thing we're left with over here is an x. So we have our answer of x equals 10. One thing I wanted to add, have you put somewhere on that note sheet that you glued in. You must check. So write that down. We have to do that check afterwards. You're very familiar with checks. You start with the equation, and then you pluck and plop. 10 plus 4, and then you show that 14 equals 14, and we're checking it off. So that's example 1. Let's do another one. Pulling from that hands-on equation packet, you're going to write down example 2 next. And the equation reads b plus 10 equals 15. Now I know that these are simple and you can probably figure out them in your head, but we are training ourselves for algebra in the future or when it gets harder. So I really want you to show your steps like I am right now. So again, we're dealing with addition, so we're going to split it up into two sides. We want to get rid of this plus 10. We can't get rid of the 15 because we can't subtract 15 from both sides. That won't work. So that's why we gravitate to this smaller number and we subtract 10 from both sides. This addition of 10 and a subtraction of 10 cancel each other out. Similar, if you want to think about it, to positives and negatives. If you have a positive 10 and a negative 10, they cancel each other out and become 0. You're adding 10 and then you're subtracting 10. How much money do you have? Nothing. So we're going to cross that out. The only thing left on this side is a b. And when we do this subtraction, notice everything's vertically, one number below the other. We have a 5. Let's finish it off with the check. Start with the equation. So used to having an x, I started to draw an x. It's b this time, plus 10 equals 15. Now 5 plus 10, and we have 15 equals 15. Here we go. Now I want you to look at that page and pick any two you want and do them to practice in your notebook page. I did one here for you just to show you that it doesn't matter which side the variable is on. This equation is number 11. It was 56 equals L plus 24. So on the right-hand side, I had to subtract the 24 so that the L was all by itself. And then I'm subtracting 24 from 56. And so my answer reads 32 equals L. Does not matter if the L is first or if the number is first. I just wanted to let you know that that is perfectly good. Now we're going to move on to multiplication. So I am on the page that says lesson 4, extra practice. That's where I'm getting these from. Example 1 again from this page is 5x equals 30. Write that down first. Now I know you know what x is, but here's how you show it. Because the 5 and the x is being multiplied together, to get rid of the multiplication, we have to divide. We are going to split this down the middle just like before. And since division can be written as a fraction, that's the form of the division that we're going to show. We're not going to use that symbol because we are doing things on either side, the right and the left. It's best to go one thing under the next, going down. So what I'd like you to get in the habit of doing is drawing the division line as a fraction bar, because that's what a fraction bar means. You're dividing. So we are going to divide each side by the coefficient. If you remember, 5 times a number is really 5 over 1 times that number. How do you get rid of a number over 1? You multiply it by its reciprocal, 1/5. This is the same as just dividing by 5. So that's why this is working, just to give the background. Because 5/5, that cancels each other out, and we just have x. So because of that, you don't have to write all that. All you have to do is draw a line, and when you're doing that, it's like you're doing the number 1, even though it's a little slanted, because 5 divided by 5 is 1, and it works, and 1 times x is just going to be x. 30 divided by 5 is going to be 6, and so now we have our answer, x equals 6. Our check is going to be very simple. 5x equals 30, and 5 times 6 equals 30. So again, it's not hard, it's just getting into the habit of drawing a fraction bar, canceling it out, showing that 5 divided by 5 is 1, and then doing it on the other side as well. From that page, we're going to do example 2 together. That is 2w equals 18. So we're going to draw that division on both sides by that fraction bar. And then we're going to put the coefficient that's next to the w below, because we want to get that 2 away from that w. It's being multiplied and we got to break up that glue. What unglues multiplication? Division. 2 divided by 2 is 1. That leaves the w by itself. 1 times w is w, and we have a 9. The check is also very quick. 2w equals 18. Yes, you have to do the check. And 18 equals 18. Here's a bonus one. I know this isn't on your sheet, but sometimes you're going to see decimals. So we're just going to label this one a bonus. Yay! 5.2 times y equals 10.4. If there's a decimal, you still can do the same process. We're going to, on the left, divide by 5.2, and on the right, we're going to divide by 5.2. 5.2 divided by 5.2 is 1. 1 times y is y. Luckily for us, this is not hard because 10 and 5 and 4 and 2 all are divisible by 2. So when we divide that, it's actually just a 2. When we check it, it's the same process. We're just going to multiply decimals now to get our 10.4 equals 10.4. And 5.2 plus 5.2 is in fact 10.4. So don't just assume that they're equal like we saw in hands-on equations. You actually do have to do that math. Ooh, I now want you to pick 3 problems, any of your choice, from this page that we haven't done, just to practice this on your own and make sure you check. Now this is going just a little step beyond the basics of just solving equations that deal with addition and subtraction. We're going to just have a little taste over the next couple of minutes to end with how to solve multi-step equations. Again, this is kind of above and beyond, but you've actually been dealing with this with hands-on equations for a couple days now. So you're going to see possibly the distributive property in equations. And if that's the case, you need to draw arrows and apply the distributive property like you've been used to with Chapter 6. Then we're going to take care of any of the variables and get them all over onto one side. It doesn't matter which side, but we're going to move them around, similar to our match and take that we did in our hands-on equations. And then we're going to get rid of the constants by subtracting them. So I'm not getting these from any packet, don't worry, and I don't even have an example number for the first one, so we're just going to, on your notebook page, copy this equation down. And this is the one example I'm going to show you with the distributive property, and then we're going to do the multi-step. So you see a number to the left of a parenthesis. We have to draw those arrows and do 2 times x and 2 times 1. So that's the distributive property. Now this is a multiple step equation to solve. We want to get the x's all on one side. We want to match and take if we can. We have an x on one side and a 2x on the other. If we match and take, we're going to be left with 1x. Here's how to show that. Whatever we do on the right, we have to do on the left. If we get rid of this x by taking it away, we are subtracting it. Again, if you take it away, now we have just subtracted it. But we also have to subtract an x on the left. So that's match and take. You're taking 1x from each side away. When you do, 2x minus an x is going to equal 1x left over. We didn't do anything with the constants yet. We have a 7 over here, and we have a 2 over here. Now it looks like what we've been doing. And to get rid of this positive 2, or an addition of 2, we have to subtract 2 from both sides. And then this becomes a 0. We're left with just x equaling 5. So it's a little bit more complicated. You have to subtract the x by doing match and take first before you can subtract the 2. But that is a distributive property multi-step equation. So this one you can put your initials next to after you copy it down. This one is just 3x plus 2 and then an x plus 6. So there's no distributive property. So initial this one. And now we're going to deal with those x's. We want to match and take if we can. I see an x over here and 3 x's over here. If I subtract out an x from both sides by matching and taking, I'm not going to have any x's over here, I'm just going to have the 6. I'm going to still have the 2 on the left, but this will mean that instead of 3 x's, I now have 2 x's. So now I have 2x plus 2 equals 6. I have to get rid next of this plus 2. So I'm going to subtract 2 from both sides. That disappears, it becomes 0, and I'm left with 2x equaling 4. Now I have to divide to get this 2 to become a 1. I'm going to divide by 2, and this becomes a 1. 1 times x is x, and we have x equals 2. Here's my check. I forgot to do the check on the first one. Oops. You can go back and do that. I forgot. 3x plus 2, x plus 6. When we pluck and plop, 3 times 2 plus 2, 2 plus 6. So we have an 8 over here, and we have a 6 plus 2, and 8 equals 8. Yay. Want you to try this one. I'm going to come back and actually show you how to do this one. It's 4x plus 5, and this is the last one for the day, and x plus 8. So go ahead and try it first, and then I'll walk you through the steps of this multi-step one. So again, no distributive property going on, but we do have a match and take to take care of first. So we're going to get rid of this x. So that's going to disappear and be left with the 8. But I have to take it away over here as well. So if I have 4 x's and I get rid of an x, I'm left with 3 of them and a plus 5. Now I have to get rid of this 5, and I'm going to do that by doing the inverse operation of subtraction. And then that will cancel each other out. I'm left with 3x equaling 3. To get rid of that 3, I'm going to divide each side by the coefficient. That becomes a 1, and I'm left with x equals 1. My check is 4x plus 5. I'm going to substitute in a 1. And I have 4 plus 5, or 9 equals 9. And with a little bit more humor, what is 6y? If y equals 3, you do not just stick them together. Calvin does not know what he's doing. You know a whole lot more than he does. I look forward to practicing this more with you tomorrow. Have a great night. Bye.